Okay, so this is Algebra 2, Chapter 5, and this is a quick review. So what I'm trying to do here is I just want you to watch. Don't want you to take notes. Don't want you to do any of that. I just want you to watch what I'm going to do in these key areas as I try to review for you to get you ready for the Chapter 5 test. Okay? So here we go. All right, first situation, multiplying polynomials. Now I've got a situation here where I've got a monomial times a binomial times a trinomial. So really what we have is three things that are multiplied together. Let's distribute the first. Okay. Negative 2n times a 2n is a negative 4n squared, and a negative 2n times a positive 3 is a negative 6n. Now, this needs to go into parentheses because those two became that one quantity. And now I have a binomial times a trinomial. So once again, I need to distribute. A negative 4n times an n squared is a negative 4n to the fourth. A negative 4n times a positive 7n is a negative 28n cubed. And a negative 4n times a negative 3, negative 4n squared times a negative 3 is a positive 12n squared. I'll do the back distribution of the negative 6n in black here. Negative 6n times n squared, negative 6n cubed. Notice I'm lining up my terms. Negative 6n times a positive 7n is a negative 42n. And finally, negative 6n times a negative 3 is a positive 18n. Last thing I want to do is combine like terms because of the way I've arranged them. I'm ready to add them up. 28 negatives and 6 more negatives. So that's a negative 34n squared. 12 positives and 42 negatives leaves you 30 negatives, right? And that's an n squared, and that's an n squared plus 18n. Another good reason to line up your factors. If you get in a hurry, and I am trying to go quickly here today, you can catch yourself. Okay, so how do you multiply three things together? You can multiply two of them together. Remember, commutative property, you can change that order, but once you get what the product of the two, that quantity must be multiplied times the third. All right, second scenario here. Let me get rid of my shade and go top of the page for you. All right, factoring. Don't forget the key in factoring is always look to factor out common factors first. Always look to factor out common factors first. So if you look at this first one, this binomial, I'm going to factor out a common 5. When I factor out a 5 out of the first term, I'm left with 9x squared. When I factor out a 5 out of the second term, I'm left with negative 4y squared. Now, at this point, I have a monomial times a binomial. If this binomial is going to factor, it's going to have to be the difference of two squares, and indeed it is. So don't forget your 5. Now, for the difference of two squares, I need two parentheses, right? Remember? Plus in the middle of one, minus in the middle of the other. I'm going to use some color here. Square root of the first term goes first in each situation. And square root of the back term, I shouldn't have got that negative sign because we already took care of that with our signs. The square root of the back term goes last, so 2y and 2y. Okay? Your plus and minus take care of the signs in between. So that's the factoring. So we had a difference of two squares, but we had to factor out common factors first. You look at the second scenario here to the right, and in this situation, I'm always looking for common factors. I don't see any. So I know I'm going to factor this by trial and error. Now, when I look at this front term, this 6x squared, I immediately know I have two possibilities. I can be 6x and x, or I can be 3x and 2x. Again, you got to keep aware of the possibilities because you got to find this correct combination. All right. The back term is a negative 10, but remember, figuring out the correct back terms is all about the middle, right? My goal is I need a positive 7x. And I have a negative 10, the factors of negative 10 to deal with it. So I just start cycling through. You know, this, I'll show you, this is my thinking. If I put a 10 here, I got a 60 on the outers. That's way too much. I know that's not going to be it. How about if I put a 1 there? I have a 6 and a 10 in the middle. Can a 6 and a 10 get me to a 7? No. Okay, so with a 6 out front and a 1 out front, it's not going to be 1 and 10. How about 5 and 2? Stick a 5 there. Outers are 30. All right, that's too much already. I'm not going to get to 7. How about if I stick the 2 there? Now I have a 12x. Well, wait a minute, 2 and 5, right? Can a 12 and a 5 get me to 7? Yes. And notice the sign. The middle term is a positive 7x. I need the 12 to be positive and the 5 to be negative. And indeed, that will give me the correct middle term. Now again, just be careful. Make sure that your back ones do multiply to what that back term is, a negative 10. And these do. So remember, it's all about the outers, multiplying the outers plus the inners to equal the middle term. And if you'll do that, you'll have the correct factorization. So there it is, 6x minus 5 times the quantity x minus 2. All right, what else? How about solve the quadratic by factoring? Okay, so this should be in your head. Hey, I've got to get this thing set equal to 0. I've got to get this thing set equal to 0. And here's another thing I'm looking at. I got a negative 12x squared. I don't like my lead term to be negative when I'm factoring. So I'm going to add a negative 12x squared to both sides. That's going to put that on the left. I have a positive 4x minus 16, and now I have it equal to 0 like I want. So if I'm going to solve by factoring, I got to factor now this trinomial, right? Well, remember the first law of factoring. Factor out common factors first. There's a common 4 in this trinomial. So I can take a 4 out of the first term, leaving me 3x squared, a 4 out of the second term, leaving me x, and a 4 out of the third term, leaving me a negative 4. Okay, I'm solving by factoring. To be honest with you, that 4 is not going to have a bearing on the problem, but I'll leave it there. And again, now what am I after? I'm after this middle trinomial, right? That's what I'm factoring. And remember, I got to end up at a positive 1x in the middle. Well, the front has to be a 3x and an x. That's the only real choice there. And my backs, I have a negative 4. I have a 4 and a 1 or a 2 and a 2. Oh, wait a minute, look. And I'll use green here in the backs. If I go 1 here, that's a 3. And if I go 4 here, can you get a 3x and a 4x to end up to be a positive 1x? Yes. If the 3's are negative and the 4x is positive. See, this is what I'm cycling through in my mind as I'm looking at my choices. It's all about the outers plus the inners totaling the middle term. When that happens, you know you have the correct factorization. Okay, let me get rid of this so we're clear here. So this is where we're at. 4 times the quantity 3x plus 4 times the quantity x minus 1 equals 0. Remember, we have to solve this quadratic. How do you finish it? Take each parentheses, each factor that has a variable and set it equal to 0. Add a negative 4 to both sides, divide both sides by 3, and there's 1 root, x equals negative 4/3. Add a positive 1 to both sides, and x equals 1, and there's the other root. Okay? Solving quadratic by factoring. All right, let's go on to the next couple scenarios here. How about solving the quadratic by taking roots? So in this situation, there's no n to the first power, x to the first power, no variable to the first power term. In that scenario, we can then solve it by taking roots. We have to isolate the squared term. I'm going to add a positive 45 to both sides, okay? And then I'm also going to, which is going to give me a 49, right? And then I'm also going to divide both sides by the 8. Okay, so here's where I'm at. Let me clear everything up. You got n squared equals 49 over 8. Now that the squared term is isolated, I can take the square root of both sides. And what do you always want to remember when you take the square root? Don't forget the plus minus. So here's where we end up. N equals plus or minus the square root of 49 over the square root of 8. Don't forget that rule. Okay, I got to simplify now my radicals. Square root of 49 is a 7. But the square root of 8 is a 2 times 4, so that ends up being 2 times the square root of 2. All right, let me clear this up, show you where we're at. We're at n equals plus or minus 7 divided by 2 times the square root of 2. If we're going to finish this, we're going to have to rationalize the denominator. This is my concern. You can't have a radical in the denominator because the radical police will get you. I have to multiply the bottom by the square root of 2. Whatever I do to the bottom, do the same thing to the top. My top is now plus or minus 7 times the square root of 2 My bottom is now, be careful here, watch what we've got. I've got this 2 right here, and then the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is a 2. So what does the bottom end up being? 2 times 2, or 4. Plus or minus 7 times the square root of 2 over 4. All right, it's about as hard as I can make that, but I wanted to do a hard one to show you, right? Okay, so here's another scenario where we can solve by taking roots. Technically, there is an x to the first power term, but it's not visible per se because this quantity is squared. When that's the situation, that's a good form for us, and we can go ahead and solve this by roots. Again, we'll have to isolate this squared quantity, the one that contains the variable. So add a positive 25 to both sides. That's going to give me, oops, I should have just left the 27. On the right, divide both sides by 3. 27 divided by 3 is 9. So the right is 9, and the left is 5x minus 2 quantity squared. Okay, I have the squared quantity isolated. Take the square root of both sides. Don't forget the plus minus. Here's where I'm at. Square roots undo squares, so I have 5x minus 2 on the left equals plus or minus, we all know the square root of 9 is 3. Should have done an imaginary one. Oh well. All right. Anyhow, so now remember, you have to split this up. 5x minus 2 equals the plus 3 one time, and 5x minus 2 equals the minus 3 the second time to find both roots. All right, on the left, add a 2 to both sides. We get 5x equals 5, and then divide both sides by 5, and we get x equal 1. On the right-hand side, add a positive 2 to both sides. We get 5x equals negative 1. Divide both sides by 5, and we get x equals negative 1/5. There are your roots, and away you go. And that's what you're looking to do. Hey, if this would have come up negative 9 here, right? Then this would be plus or minus 3i. And the only difference here is then you would have left it as a complex number. So you would have left it, you would have moved the 2, and then you would have moved the 5. And in each case, then you would end up with a complex numbered answer. Okay, let's go on to the next one, number 5, completing the square. Completing the square. Okay, so when we complete the square here, this is an equation. So what I want to do to complete the square is I'm really going to solve this by factoring as well. So I'm going to complete the square, and I'm going to solve by, by taking roots. So I'm going to complete the square, and I'm going to solve by taking roots. All right, so how am I going to do that? First thing I'm going to do is I'm going to isolate the variable terms. So I'm going to add a negative 22 to both sides. So now I'm at 2x squared minus 16x equals negative 22. I now need to get my lead term to be 1x squared. So I'm going to factor out the 2. Sometimes you'll end up with fractions on these, but that's okay. We can handle that. All right, let me give myself a little bit more room here. Okay. So this is where we're at right now. Now, do you remember how to complete the square? We're going to make this binomial into a trinomial, and we're going to make it into a perfect square trinomial. And the method's pretty easy, okay? What you do is you take the middle term, doesn't matter whether it's positive or negative. So I'm going to do this off to the right here. You take it, you divide it by 2, that's a 4, and then you square it, and that's a 16. And that's what you want to put into the blank. And it's always positive because you're always squaring. Even if you square a negative 4 times negative 4, it's positive 16. So that's always positive. That's why you said you don't have to worry about the negative. Okay, well, here's the key. I have just changed the value of this equation, because I put this 16 in here. But remember, not only did I put 16 on the left side, I really put a positive 32 on the left-hand side. And the only way I'm going to keep this balanced and not change the value is to also add a positive 32 on the right-hand side. Okay, do you remember that? Hope so. All right, so now let's complete the square on the left. Remember how you do it? The square root of the front term goes in the front. The square root of the back term goes in the back. The sign of the middle goes in the middle, and it's that quantity squared. And believe me, if you multiplied out x minus 4 quantity squared, you get right back to that original. What's my right-hand side? It is a 10. Okay, I'm going to finish this by taking roots, right? So I got a little bit of room here. I'd be careful. Let's isolate the squared term. That is now a 5. Agreed? Let's take the square root of both sides. Don't forget the plus minus. So where am I at right now? X minus 4 equals plus or minus the square root of 5. Now, there's no need to split this up because I won't be able to do anything with the square root of 5. I'll simply add a positive 4 to both sides, and there are my two roots. X equals 4 plus or minus the square root of 5, and we're done. So two roots, x equals 4 plus square root of 5, and the other one, x equals 4 minus the square root of 5. Okay, then remember we got to the third method in solving quadratics. Remember, quadratics can be solved three ways: taking the by factoring, by taking the square root of both sides, or by using the quadratic equation. Some call it the quadratic formula. This is something everybody should have memorized: negative b plus or minus the square root of b squared minus 4ac all over 2a. And don't forget where the a, b, and c come from. Standard form of a quadratic equation. What is a? The coefficient of the squared term. What is b? The coefficient of the x to the first power term. What is c? The constant, the number. Okay? All right, so let's go ahead and put this in the proper form first. We got to add a negative 2x to both sides. 2x squared minus 2x, whoops, minus 5. Oh, thank you, smartboard. Minus 2x minus 5 equals 0. Okay, now I know my a is a 2. I know my b is a negative 2. And I know my c is a negative 5. I'm going to come over here and sub it into the quadratic equation. So x equals negative b, right? So this is negative, and what's my b? Use my green here, a negative 2. Quadratic formula, plus or minus the square root. And then I'm going to take b and square it, so that's a negative 2 squared. I have a negative 4 times my a value, which in this case is a 2, times my c value, which in this case is a negative 5. And this is all over 2 times a, and my a is a 2. Okay, be careful with the discriminant, which is the radicand, right? Just be careful, follow the order of operations. Negative 2 times a negative 2 is a 4. And then remember, this whole back part is one quantity. So negative 4 times a 2 is a negative 8. And negative 8 times a negative 5 is a positive 40. Okay? So do you see what the radicand is going to be? So let me clean this up. X equals negative a negative 2, positive 2, plus or minus the square root of 44 over 4. Okay, simplify the radicand. 4 times 11, we all know the square root of 4 is 2. Now be careful finishing this. Remember, this is a 2 times 2. If you're going to do the shortcut and you're going to try to reduce this thing, this 2 must divide into both things. Because remember, let me just take a second. Technically, you're supposed to split it up. And you see now how you're left with 1/2 plus or minus the square root of 11 over 2, which again, when you bring it together, so here on the left, shortcut, if I'm going to do it, I've got to divide that 2 into both portions of the numerator. Final answer, x equals, and this is 1, x equals 1 plus or minus the square root of 11 over the common denominator of 2. And there you go. All right, quadratics, they're awesome. Okay, how about some complex numbers and absolute value? Pretty simplistic. Remember, complex numbers, you have the real axis and the imaginary axis on a complex plane. That's pretty simplistic. So what is the real value? The real value of this is a negative 3. And what is the imaginary value? Positive 2i, right? That's pretty easy. No sweat there. Hey, I want the absolute value of z. So in effect, I want the absolute value of negative 3 plus 2i. Remember, this is the Pythagorean theorem. the first squared plus the second squared. Okay, don't include the I. It's not a 2i squared, it's the coefficient of that I. So just a 2 squared. So here we have the square root of 9 plus 4, and in this case we've got the square root of 13, and that's it. What's the absolute value? How far is this number from 0? It is the square root of 13, and we use the Pythagorean theorem to figure it out. We're just doing a right triangle and figuring out the value of the hypotenuse of a right triangle. All right, adding complex numbers. This is pretty simplistic. Okay, I made it as hard as I could. I have a negative sign to distribute. 3 positives and 4 negatives, right? Add the real part and the real part leaves me a -1. And look, don't forget, this negative has to get distributed here as well. So this ends up being 2 negative i's and a -5i for a grand total of -7i, right? Add the real parts, add the imaginary parts. What about multiplying two complex numbers? Well, we know how to multiply binomials, right? Distribute. 3 times 4 is 12. 3 times a positive 5i, positive 15i. You do the back in black. -2i times a 4, -8i. -2i times a positive 5i, -10i squared. All right, couple things. Remember, every I squared is a -1. So what do we really have? -10 times -1, that's a positive 10. Add that to our 12, and that gives you a 22. And what do you have for your imaginary part? 15 negatives. I'm doing it right here, right? Or I'm sorry, 15 positives and 8 negatives leaves me 7 positives. 22 plus 7i is the value of that. Okay, do you remember how to simplify like I to the 135th? Remember the pattern. It's I, -1, I, 1, right? And I comes from I to the first, the -1 comes from I squared, the -I comes from I cubed, and the 1 comes from I to the fourth. And all you have to do is take the 135 and divide it by 4 in your calculator, and you read the remainder. So whenever it's I, the remainder is 0.25. Whenever it's I squared, it's 0.5. Whenever it's I cubed, it's 0.75. And whenever it's 4, there is no remainder. So you just take your calculator and you divide 135 by 4. And what's the remainder? It's 0.75, right? So what's our answer? What is an I cubed? It's a -I, and that would be my answer. Okay? If I would have gotten I squared, if it would have been 0.5, I would say an I squared is a -1. I would have put -1. All right, just a couple more. Don't forget the discriminant. What is the discriminant? The discriminant is the radicand, the b squared minus 4ac. It'll allow us to determine the types of solutions. First scenario, the value of that radicand is positive, meaning it's greater than 0. You get a positive, you have a positive radicand. I don't know, a +1, a +4, a +7, a +11, a 300, a 789, a 22.4, whatever. It's positive. Even a 9/2, whatever. Well, here's the reality. Then it is 2 real number solutions. 2 real number solutions. Now, more specifically, if the radicand is a perfect square, that would be like the square root of 4, the square root of 9, the square root of 36, etc., etc., perfect square. Then you're going to end up with 2 rational number solutions. So they're real numbers, but specifically they are 2 rational numbers. If it's not a perfect square, then you're going to end up with 2 irrational number solutions, right? Like the square root, 3 plus the square root of 7, something like that, right? So anytime it's greater than 0, you have 2 real number solutions. What about if you do it and you get exactly 0? Well, what this is when both roots are exactly the same, and this is 1 real number solution. Here's a quick example of one, though I'm not going to do the actual radicand. What if when you were factoring, you got x minus 3 times 20, x minus 3 equals 0. So what's the answer to this root? 3. What's the answer to that root? Same 1, 3. It's one answer. That's the scenario that gives you a 0 in the radicand. Okay? The third scenario is when you get a negative number, right? Less than 0. And in this case, remember, you're going to take the square root of a negative quantity. When you take an even root of a negative quantity, you always get imaginary numbers. So we say 2 complex conjugates. 2 complex conjugates. For example, if one answer was x equals 3 minus 2i, then the other root is always x equals 3 plus 2i. Those two are conjugates. All right? 2 complex conjugates. All right, the last thing in this chapter you got to be careful with is quadratic inequalities. And to be honest with you, I just don't have time in this quick review to go into it, but I will refresh your memory on this. Remember, these are going to turn out to be either conjunctions or a disjunction. And therefore, you need to go back and look at your notes and make sure that you remember when you solve a quadratic inequality that you expect either a conjunction or disjunction as a final solution. All right, I hope that helps. You can go back and watch it a few times if you need to. Hope you get ready for your test.